Woohoo! Let's do ratio tables. Ratio tables are fun. They're going to feel really familiar to all the other ratio stuff. So let's get started. Okay, now to make yellow icing, we need 6 drops of yellow food coloring for every 1 cup of white icing. So does this sound kind of familiar? Sound maybe kind of like a ratio? Good. So we have 6 drops of food. Actually, let's do some labels. So let's start with labeling food coloring, and I am going to, underneath this, I'm going to label this white icing. And again, this is why we have this table. Okay, here we go. So we need 6 drops of yellow food coloring with every 1 cup of white icing. So 6 drops of food coloring, 1 cup white icing. And it says, how much yellow food coloring should you mix to get 5 cups of white icing? So that means I'm going to be down here, and I'm going to be putting that 5 there. So how do I get from here to here without adding? We're going to either use multiplication or division. So whenever we use ratio tables, we're always looking at multiplication or division. How do you get from 1 to 5 through multiplication or division? First of all, are we getting larger or smaller? We're getting larger, which means we need to multiply. So what are we multiplying by? Good, we multiply by 5. And remember how we've talked about, if we're going to do it there, we might as well do it, on the other part. So I have to do that here too. So this is going to be times 5. 6 times 5 is 30. Ta-da! Which means it takes 30 drops of yellow food coloring in 5 cups of white icing to get the same shade, to get the equivalent shade of saying, hey, if I put 6 drops for 1 cup, I need 30 drops for 5. And that's all we're doing. Technically, if you needed to, we could keep counting. So 1 cup, 2 cup, 3 cup, 4 cup, and then 5 cup, and you can just keep adding it that way. This is kind of the shortcut. Let's go into another one. Okay, a patient receives 1 liter of IV fluids every 8 hours. Sometimes that happens. At that rate, how many hours will it take to receive 4 liters of IV fluids? So again, I'm going to set up my table just like I did before. So this is going to be IV fluids. I know it doesn't look like it, and I'm going to try and draw my straight line. You guys know how that goes. And this is my hours. So I'm going with the information I have. 1 liter for 8 hours. Okay. Now, how many hours? So we're down here. This is going to be our question mark to receive 4 liters. So this time I'm going to do this using the actual table method instead. So let's see. Here's 2 liters, 3 liters, and 4 liters. Okay. So we know 1 liter in 8 hours. So 2 liters is going to be 16. Okay. So then we add another 8, and we're at 24. And we add another 8, and we're at 32. So how many hours does it take to receive 4 liters? That would be this part right here. So it would take 32 hours. So we could have jumped. You could have done the jumpy thing. So we could have gone, okay, 1 liter to 4 liters. What do? You multiply by 4. And then we could have done it this way and said times 4. Or you can do it the table. It's up to you. Some people need to see that table out. That's perfectly fine. If you're comfortable doing the jump, go ahead and do the jump. Both ways. Both ways are perfectly good. Now, let's look at another one. Cans of corn are on sale at 10 for $4. Find the cost of 15 cans. So this is just like what we were talking about before, which is why I'm going back to a table. So cans of corn. So this is going to be my corn. And This is going to be the cost. So we know 10 cans, $4. Okay, now how can we do this since we are looking at 15 cans? So there's nothing, let's see. Okay, so if I do 11, that's not going to work because I don't understand how many it's going to be for just one. So I can't do 12, so I can only count by tens. So I can tell you, I understand that if I have 20 cans, that's going to be $8. If I have 30 cans, that's going to be $12, but that's not helping us because we want to go the other way. We want to find out how much it is for 15 cans. So what I'm going to do is I'm going to go back to some previous stuff that we've done. So I want you to think about this. So if it's 10 cans for $4, okay, what do they have in common? How can I simplify this? Good. They have a 2, so I'm going to divide it by 2. And then that would be 5 over 2, which means 5 cans for every $2. Is this, if I make a table using this, could I get to 15 cans? Well, let's find out. So I'm going to go back and I'm going to erase a lot of this stuff that we just did here to try and figure this out. So what we're going to do instead is we're going to say 5 cans for $2, 10 cans for $4. What are we counting by in the corn cans, in the number of cans, I'm sorry, of corn? 5, 10, what do you think comes next? 15, 20, 25. Okay, we don't have to keep going that high. And so then it goes $2 and then $4. And then this would be $6. This would be $8. This would be $10. So how much does it cost for 15 cans? Ding, 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 ding. Good job. We are right in here, which means that the cost for 15 cans of corn, this expensive corn, is $6. Okay, so we tried doing our regular table, but it wasn't working for us because there wasn't an even number. We can't count by tens to get to 15. That's not how this works. So 10, 20, 30, wait, there's no 15 in there. So we had to go backwards and say, okay, let's look at a way to find the simplest ratio. Wait, ratios? Yes, Ms. Curtin. Yes, I know what those are. I recognize that word. We're back. Okay, sorry. You know how excited I get about this stuff. So we're going to the next one. A child's height measures 105 centimeters. Estimate her height in inches if 25 centimeters is approximately 10 inches. Oh boy, I am just slightly confused by all of this. So I'm looking at the 25 and I don't think 25 centimeters into 105 centimeters, so I want something a lot smaller. So I'm going back to what we were doing before because I kind of, you go with what's comfortable. So I'm going to go with that 25 over 10. And then I'm going to divide it by 5 because that's their greatest common factor. And so it's 5 centimeters for every 2 inches. Now I can start making my chart. So my chart, let's do the chart in green. Okay, so this is going to be centimeters. And this is going to be inches. Okay, so we know 5 centimeters for every 2 inches. Now I'm trying to get to 105 centimeters and however many inches. So I can take the shortcut now and try that. So let's take that shortcut and say 5 times what is 105. So in order to do this, I'm going to use 105, I'm going to divide it by 5. 5 goes into 10 2 times. With a 10, subtract, bring down, and 5. So I need to multiply this by 25 to get to 105. And remember, if we're doing that with the top, you have to do that with the bottom. So if I multiply this by 25, what is 2 times 25? Good. That's 50. I can look at it for 25 into 105, but I know that if we're talking about money here, there is no way I can use quarters, because that's 25 cents, to make $1.05. I can make $1.25, I can make $1, but there's no way to use my quarters to make $1.05. I'd have to have change, and I only have quarters. So this is why I went back to finding that basic for the ratios. And then I can easily say, okay, this, I need to figure out how many sets of 5 I need to make 105. And remember, when you're doing that, the how many sets of 5 do you need to make 105, you can definitely use division to help us do that. So that's just a thought bubble to help you out. And also do not forget that whenever you multiply up here, you have to multiply down here. If you divide up here, you have to divide down here. Same numbers. They don't change. So this is just kind of a preview of what we're going to be getting into next. Remember, this hasn't been taught yet, so don't panic if you don't get it. We're going to practice more. Practice makes perfect. See you guys later. Bye.